start EE1 today. EE1 is where we're going to talk about exponents. Now, before we can go too far into exponents, we do need to understand prime and composite numbers. A prime number can be broken down by one and itself only. A composite number can be broken down many times. Now, I do want to point out a few misconceptions that I had growing up, is that 2 is a prime number. Even though 2 is an even number, it is still prime. It is the only even prime number that we have. Another misconception I always had was a 9. 9 is odd, but that does not mean that it is prime. 9 can be broken down by 9 and 1 and 3 times 3. So it can be broken down more than just 1 and 9. That always has confused students with thinking that an odd number is a prime number. That is not the case. 27 is an odd number, but it is not a prime number. There are many things that go along with that idea. However, there are some odd numbers that are prime, and there are some that are composite. But the number 2 is our only even prime number. So what we're going to do now is we're going to take 32 and we're going to break it down to all prime numbers, if I can get that out. All right, 32. So 32. There's several different ways that we can break down 32. We could say 16 and 2. We could say 8 and 4. There's a lot of different things we could do. I'm going to take 8 and 4. So with 8 and 4, we're going to write it just like this. What this means is 8 times 4 is going to give me 32. Now, 8 and 4 are composite numbers. They can be broken down again. So let's break down 8. 8 can be broken down by 4 and 2. Now notice what I'm fixing to do to the 2. I'm going to circle it because 2, like we just said earlier, is the only even prime number. So I cannot break 2 down anymore unless I divide by 1 or itself, and it's not going to help me any. 4 can be broken down into 2 times 2. I'm circling those because, again, those are prime numbers. Now, with 4, we're going to break that down into 2. We got 2 times 2 and circle those. So here's what we're going to do. We're going to take our prime factorization and we're going to write it out. So we're going to say 2 times 2 times 2 times 2 times 2. This is our prime factorization of 32. Now, a lot of times students may have a 4 in here. That cannot be a prime factorization because 4 is not prime. The key word in prime factorization is prime. So now we're going to put it in exponential form. So what exponential form means is we're going to be repetitively adding. Well, think about what, we're going to be repetitively multiplying. So if you think about what multiplication is repetitive addition. With exponential form, we're going to be repetitively multiplying. So that's what we're doing here. But in exponential form, we have a base number. The base number is our big number. It's the number that's being multiplied over and over and over. Your exponent is the number of times you are multiplying that base. We are multiplying it 5 times. We have 1, 2, 3, 4, 5. So we're going to have 2 to the 5th power as our exponential form. 2 to the 5th power means 2 times 2 times 2 times 2 times 2, which also means 32. All right, so let's look at another. We have 27. We're going to do prime factorization of 27, which would be, we could do 3 times 9. 3 is prime, so we're going to circle it. We can't do anything else with that to break it down. 9 we can break down and do 3 times 3, and those are prime as well. So our prime factorization here is 3 times 3 times 3. In exponential form, it's going to be a base of 3 because we are multiplying 3 repetitively. This is our base. And then our exponent is going to be 3 as well here because we have 3 3's being multiplied. So 3 to the 3rd power, or we also can call that 3 cubed, is going to be 27. All right, 12. We're going to break down 12. We could use 3 and 4, 6 and 2. Either one of those works. So I'm going to do 3 and 4. I'm going to circle my 3 because it's prime. I'm going to break down 4 into 2 times 2, circling those because those are also prime. Your prime factorization for 12 is 2 times 2 times 3. Your exponential form for 12 is 2, because we have 2 of that. We have two 2's. We're going to put the exponent of 2 and then times 3. So your exponential form for 12 is 2 to the second power, or we can call that squared, times 3. Last one, 125. With 125, we can break this down by 5. Now, if you didn't know that, or what we could break it down by, sorry, that kind of went there. This 5, the ending in 5 means we can divide by 5. So if you didn't know that, grab out your calculator and put in 125 divided by 5, and you're going to get 25 times 5. Or you can think about 5 quarters. If you had 5 quarters, you would have $1.25 or 125 pennies. So we would have 25 times 5. Now we can break down 25 by doing 5 times 5. So our prime factorization here is 5 times 5 times 5. And our exponential form, our base would be 5. And our exponent would be 3, because we have 3 5s. So your base is what is being multiplied over and over and over. And your exponent, it tells you how many times to multiply the base. So we're going to have our base of 5, our exponent of 3. We can also call this 5 cubed. So just remember, anytime you're doing prime factorization, you're getting those numbers as low as they can go without dividing by 1 or itself again. Just stop whenever you get to prime numbers.